So now the instrumentation part, okay, IA. So there are two ways to analyze your data here. First is ion chromatography, your IC. Okay, you have your dynamics inside your analytical chemistry lab. Okay, the one you go to for your CM3292. You can also use the conventional UV-vis method here by calorimetry. Okay, so in terms of sample preparation, right? So you want to see that you prepare the instrument first. Okay, instrument first. That means you set up before you attend to your sample. And these are just some general guidelines. You should use ultra pure water using from the same filter, right? 18 mega ohm. Okay, in terms of resistance is good, right? And always check the filter. When was it the last time it was the serviceman came, okay, and changed the filter. Okay. Take note of the effect of the weather conditions and the NO2 level when you prepare the solutions. Because you know when you have cool windy weather, right, you have low NO2 level, okay, because you have more wind. You have hot and still weather will generate more NO2. So think of how to mitigate the potential, this range of standards, the weather conditions. Take note of this very subtle thing of weather. Is it cloudy? Is it storming? Is it raining? Okay. Right. After we prepare the standard solutions, then we prepare the sample and the standard tube together. We should do this in such a sequence. Why standard, then sample, then standard tube? Okay, why not you prepare sample, then standard? Okay, you need to understand then it. Okay, because your samples is limited. Standards you can prepare again, because it's lab you have more abundance. So you don't want to waste time. 2 weeks. Once you change the time frame, it's a different scenario anymore. So you want to make sure that if you have error because you're not familiar, you get it wrong on the first time in a standard, it's like a training. Then you realize, oh, there's some error. Luckily, you haven't touched the sample yet. Okay? So then you only add the color reagents after you finish the preparation for the sample and standard tubes. Everything finished, then you do. Because if not, you have some human error. Okay? You also may have forgotten which one you have prepared or not. Okay? Remember, record exactly which tubes are being analyzed. Okay, you label, right, permanent marker and which order. Okay, then you place sample blanks, then diffusion tubes right in the test tube rack. Okay, loosen the red cap of the sequence. Okay, record which tubes analyze. Okay, then now we proceed to the first method, the UV method. Okay, after you're done, right, because remember when you carry these tubes to your lab, you need to enclose it with a cap so that you don't want to have more or gas going in. So you seal it off. Then you bring to the lab, you remove the red cap, keep track of which cap came off, right, from which tap, because again you don't want interference. Then using the same Finnpipette rifles, you change the pipette. Tip: add 0.6 ml of water to each of the tubes. Okay, just top it up, add the color reagent, replace the cap, and shake the tube for 60 seconds. You want to, let it totally react with whatever you trap inside the trapping solution. 20 seconds, and then you leave the tube standing for 40 minutes. Then you analyze the tube promptly, okay? Because it's also time dependent. Next is you add 5 ml of water to each tube. Okay, if the tube is a standard tube, then you add 5 ml, okay, of the standards. Replace the cap, shake the tube for 20 seconds. Again, we don't want to cross use the caps. Then you leave the tube to stand for 10 minutes on the test tube rack, right? Then you gently syringe filter each sample to the cuvette. Okay, you can use the auto sampler, or no, there's no auto sampler for UVs, but now we are going to the ion chromatography here. Then you can use the same filter for 5 samples, right? But you should wash the filter with the ultra pure water between every sample. Okay. So in the IC, right, same thing. The ultra pure water should be about 18 mega ohm resistance. This regards to how much of the ions, okay, inside you have. Now, most of the reagents they use here should be your analytical grade, AR grade or better. So I'll put the star here, right, to illustrate what it means here. The conditions, all these are just make sure you check. It's preset, but you make sure that you have, it runs at 4.5 millimolar sodium carbonate. This amount of bicarbonate eluent. Okay, hit basic, and then you have this is injection. Okay, more of analytical research. Now here is the stars. You will learn next time, right, that in your research or work in company that there's different grades of purchased chemical. If I want to say, can I have a bottle of ethanol, please buy it, then you go and research. But got many kinds, not just because of different bottles, different size, but different grade. What kind of grade? You have your AR grade, analytical grade, okay, or some people call ACS grade. But A grade means you can say it's normal, okay, good enough. But what's better will be your HPLC grade, okay, because this is what you want to use for purification to analyze high purity. You can't use it for analytical work. So when do you use your AR grade? AR grade is like when you want to use for cleaning purpose, right? You want to use for just wash up, work up in maybe synthesis, that's fine. But you want to use it for analysis, you don't want these contaminants because of a slightly lower purity, okay, than the requirement, okay. Then you also have others that's lab grade, so you need to check the grades and clarify with your manager or your professors what do you want. If you use the wrong one and people didn't know, they just see a bottle, ethanol. People, when they transfer from a bottle to the small spray bottle, you don't put AR, you don't put GR grade, right? You just take it as ethanol. So that's when some hiccups occur if not careful. So back to analysis using UV, right? Okay. So, okay. Here, okay. Dionix, okay. You can use this Dionix, which is located in the CM3292 lab, okay. Then you can just analyze, according to your lab procedures. Again, not in this module here, but I just want to give you a complete picture. You need to have buffer solutions. Remember, this is your non-ionic this organic surfactant. Okay, bridge treatment 35 by Thermo Fisher. Then you need to do some preparation of your sample. Okay, this is not covered, but here I want you to understand that you want to see the color, right? So there must be kind of a organic reactions there. You have 0.25 grams of sulfonamide. This is structure. 2.5 mils of concentrated HCl. Your NEDA, your N1 naphtha diethylamine dihydrochloride here. So the structure is below, right? Then you make up to the solution, the volumetric flux to allow mixing. When you add them together, what happens is we have a azodine formation. So in the first step, your sulfonamide, right, reacts with an acid. Okay, you can use corn HCl or any oxidizing agent here. Then you loses the H, right, generating a very good electrophile, and then being attacked by the naphthalene, NEDA here, attack, and then they join to form this NN bridge, NN double bond bridge. This highly conjugated pi system give rise of a very nice color. I think it's pink to purple color. Then you can observe, you can use a UV detector to test. Okay. So these are some of different color you can see, depends on the functional group, on the structure, and has a relationship towards the extent of the pi system in this highly conjugated system. Then of course you mix it up, right? You do it for the rest of the sample, and you need to do dilutions here. Okay, you just can't do it one time, because what if your solution is too concentrated, it exceeds the detection range, then you can't trust it, right? So you need to do some dilution. Okay, you only need to dilute, okay, if you expect the concentration of analysis of your analyte to be more than 25 millimolar. Okay, and the diluents can last for 4 weeks before you need to replace this diluent. Okay, don't just add water to dilute. Okay, because your substance here is organic. Water cannot dissolve organic. This is quite organic, quite non-polar. So we need to use some surfactant, right? Surfactant can dissolve maybe of aqueous and organic substances and mix them together. You want them to form at least not a heterogeneous mixture, but somewhat homogeneous mixture. So therefore, you need to take care of the duration, the durability of this diluent, what you add, okay? So now, what have you learned? We have learned that air quality, we have a responsibility, right? Driving, don't drive for car, diesels or petrol car. Do you take public transport, right? We have to care because it's our environment. We live in it, we own it. It is about our responsibility as a citizen. Citizenship, 好公民. Your lifestyle. It's okay to have your ambition. Own a car. You don't have to explain your reason. At some point, drive a car, okay? But if you need to drive because of long distance, think about how we can mitigate the risk, protect the environment. And if your loved ones or friends drive a lot, too much, do not understand SDG, don't understand the environment, don't study chemistry, you might want to give them some gentle, tactful advice. Tell them that, hey, we share the environment. You want to play a part? Be my green friend? Okay? Talk to them. Educate. Education is always key. And if you drive, like I drive, okay? I drive, what can we do to help? Don't accelerate unnecessarily. Control emotions. Even if you have a bad driver, people speed past you, overtake you, don't just give the finger, don't just overtake them, okay? No. Okay? Just focus on your own driving, okay? They are bad, let them be bad. We focus on our own, with grace, with good manners. Get your car to service regularly. Once a year, twice a year. Too much, not so effective. Too long, you might save money, but not good for your car as well. Okay, you may even pay more money next time to get it repaired. Turn off your engine if you're not moving for more than 1 minute. Okay. Yes, I think some recent rules saying that if your car is stationary for after certain time, I think it was 2.5 minutes. You clarify on that on LTA website, then you get fined. Okay, because stationary, you're not having a productive combustion of fuel, so you're just emitting pollutants. Okay, not good. And you know that you have incomplete combustion, the CO can poison you and can kill you, right? NOx also can do that long term. Stick to speed limit for safety reasons, for environmental reasons, for your own reason, your health, okay? Especially on expressway, 90 kilometers per second, 90 kilometers per hour means you stick to that. You don't go 91, okay? Don't speed, okay? Even if you're very high, very angry. And be very careful about buying any retrofitting. People like to model their car, make it very nice, initial D. But if it's not accordance to the LTA, I think it's not good. Of course, you might save on fuels, like I've explained, but overall, you might pay a higher price. Okay? Maybe in a similar fashion to the Volkswagen Dieselgate. So now it's your turn. Do come up with your own research question and bring to the class about air sampling with regards to NO2 sampling. Okay, what do you want to investigate and what kind of data do you need? Because if you cannot get the data you need, you could need to go back to your research question, change or modify your research question so that you go back to, oh, this is the data I need. Can I get them? Yes, okay, then it feeds to the research question. Then you know that you can proceed. Okay, so in class I will see you soon. I might provide you some data, but at least we'll talk a bit more on air sampling. So I'll see you soon. Cheers.